So we'll discuss now what amortized analysis is and look at a particular method for doing such analysis. Sometimes we're looking at an individual worst case, and that may be too severe. In particular, we may want to know the total worst case for a sequence of operations, and it may be that some of those operations are cheap, while only certain of them are expensive. So if we look at the worst case operation for any one and multiply that by the total, it may be overstating the total cost. As an example, for a dynamic array, we only resize every so often. Most of the time we're doing a constant time operation of just adding an element. It's only when we fully reach the capacity that we have to resize. So the question is, what's the total cost if you have to insert a bunch of items? All right. So here's the definition of amortized cost. If we have a sequence of n operations, the amortized cost is the cost of those n operations divided by n. Okay, this is similar in spirit to, let's say you buy a car for, I don't know, $6,000, okay? And you figure it's going to last you 5 years. Now, you have two possibilities. One, you pay the $6,000, and then 5 years later, you have to pony up another $6,000. Another option would be to put aside money every month, right? So 5 years is 60 months. So if you put away $100 a month, once the 5 years is over, then when it's time to buy a new car for $6,000, you'll have $6,000 in your bank account. And so there, that amortized cost of the monthly cost is $100 a month. Whereas the worst case monthly cost is actually $6,000. It's zero for 59 months, and then it's $6,000 after 1 month. So you can see that that amortized cost gives you a more balanced understanding. If you really want to know what's the most I spend in every month, the answer, yes, is $6,000. But if you want to know sort of on average what am I spending, $100 is a more reasonable number. So that's why we do this amortized analysis, to get a more nuanced picture of what it looks like for a succession of operations. So let's look at the aggregate method of doing amortized analysis. And the aggregate method really says, let's look at the definition of what an amortized cost is and use that to directly calculate it. So we're going to look at the example of a dynamic array, and we're going to do n calls to pushback. We're going to start with an empty array and n times call pushback. And then we'll find out what the amortized cost is of a single call to pushback. We know the worst case time is order n. So let's define C sub I as the cost of the ith insertion. So we're interested in C1 to Cn. So Ci is, clearly it's 1, because we have got to and what we're going to count for a second here is writing into the array. So the cost is 1 because we have to write in this ith element that we're adding, okay? Regardless of whether or not we need to resize. If we need to resize, first question is, when do we need to resize? We need to resize if our capacity is used up. That is, if the size is equal to the capacity. Well, when does that happen? That happens if the previous insertion filled it up. That is, made it a full power of 2, because in our case, we're always doubling the size. So that says on the ith insertion, we're going to have to resize if the ith minus 1 filled it up. That is, the I minus 1 is a power of 2. And if we don't have to resize, there's no additional cost. It's just 0. So the total amortized cost is really the sum of the n actual costs divided by n. So that's a summation from I equals 1 to n of C sub I. And again, C sub I is the cost of that ith insertion. Well, that's equal to n because every C sub I has a cost of 1. So we sum that n times, that's n, plus then the summation from, what's this? This looks a little complicated. So j equals 1 to the floor of log base 2 of n minus 1 of 2 to the j. That just really says the power of 2's all the way up to n minus 1. Okay, so I'll give an example. If n is 100, the power of 2's are going to be 1, 2, 4, 8, 16, 32, and 64. Okay, and it's the summation of all of those. Well, that summation is just order n, right? where basically take powers of 2 up to, but not including n, and that is going to be no more than 2n. So we've got n plus something no more than 2n, that's clearly order n divided by n, and that's just order 1. So what we've determined then is that we have a amortized cost for each insertion of order 1. Our worst case cost is still order n. So if we want to know how long it's going to take in the worst case for any particular insertion, it's order n, but our amortized cost is order 1. In the next video, we're going to look at an alternative way to do this amortized analysis.